All right, let's take a look at how to solve some quadratic equations. We'll start with some perfect squares and then move our way up to generic quadratic equations. All right, let's try this. X squared equals 4. We already saw to get rid of square, you have to do what? Take square roots. Good. And if you take square roots, you have to remember to do what? When you get rid of even roots, plus minus. Good. So x equals plus or minus square root of 4, and square root of 4 is 2. So x is either 2 or negative 2. Why is that? Because when you square 2, you get 4. When you square negative 2, you also get 4. Now let's take a look at x squared equals negative 4. How are you going to do that? Well, you can do the same thing, plus or minus square root of negative 4. But do you remember what negative 4 square root is? Square root of negative 1 is I, so square root negative 4 is 2i. And so you're going to have x equals 2i or negative 2i. Look at the similarity of these two equations. The only difference is here you have real solutions, here you have imaginary solutions. That really is the only difference. All right, try that. Again, take square root, so plus or minus. So x is either square root 5 or x is negative square root 5. What if you have negative 5? What's the difference? Take square root, so you're going to get square root 5i or negative square root 5i. Same thing here, except here we have to get rid of that plus 3. So you're going to subtract 3 from both sides. So that means x equals negative 3 plus the square root 5 or negative 3 minus the square root 5. The negative 3 came from subtracting the 3. All right, let's try here. Same thing. So x plus 3 equals plus or minus square root negative 5, which is the same as plus or minus square root 5i. And now subtract 3 from both sides, and there's your answers. All right, how about this? 4 times x plus 3 squared equals 5. Divide both sides by 4. And so x plus 3 would equal plus or minus square root of this number 5/4, which is square root 5 over square root 4, which will give you square root 5/2. And to get rid of the plus 3, you'll have to subtract 3. So negative 3 plus square root 5/2, negative 3 minus square root 5/2. Let's try that. Same exact thing. The only difference is you're going to end up with square root 5/2 I. Remember, this is the real part, this is the imaginary part. All right, so what you're noticing here is that if you have a perfect square, something square equaling a number, we can solve. So we're going to look at a technique called completing the square. So let's take a look at x squared plus 6x and take a look and see what can we add so that it's a perfect square. So remember, let's bring our algebra tiles back, assuming x is positive and large so we can visualize this. What's x squared? That's x by x squared. 6x's, so we're going to 1, 2, 3x's here. To make a perfect square out of it, I can't just put them all here, then I'll just have rectangles. So if I put 3 here, I'll have to put 3 this way. So let's put 3 this way. So that's my 6x. So I have x squared plus 6x's. If I were to put the remaining pieces here, I would have a perfect square because this is x plus 3, this is x plus 3. So how many do I need? I need 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like I need 9 here to make a perfect square of x plus 3 by x plus 3. Can you see? So how do we get that? Well, we took the 6x, we put half of them here and half of them here. So half of 6 is 3, right? 1, 2, 3. And 3 squared is 9. And that 9 is this 9 right here. Can you see? So that's 3 by 3. 3 squared is 9. So 9 is what you had to add. This is x plus 3 squared. All right, let's try this on your own. So how do we complete squares? You take the middle number here, chop it in half, and square it. That's how you know what this is going to be. 4 halves would be 2. 2 squared will be 4, which will give you x plus 2 bracket squared. All right, try that on your own. Half of negative 10 is negative 5. Negative 5 squared is 25, and that'll give you x minus 5 squared. Look, if there's a plus here, you have a plus here. If you have a minus here, you have a minus here. This number here is half of that squared. And this number here is simply half of that. So half of negative 10 is negative 5. Half of 4 is 2. Half of 6 is 3. All right, let's try solving quadratic equations by completing the squares. So we saw that we can factor and set each factor to 0. So if you have x squared plus 6x minus 14 equaling 0, two numbers, multiply to give you 14, multiply to give you negative 14, add to give you 6. Well, 2 and 7 don't work, 1 and 14 don't work, so nothing works to factor. So instead of factoring, we're going to try completing the square. So look, we're going to take the 14 and add it to the other side. Now I have x squared plus 6x. What can I add to make it a perfect square? We said take half of the middle number, which is 6 halves, square it, that will be 9. So let's add 9 to both sides. How is that going to help us? It looks like we're making it even more complicated, but we're not. Look, x squared plus 6x plus 9 is a perfect square. So we'll get x plus 3 bracket squared equals 23. This is clever because now we can solve. This equation we could not solve, we could not factor, but this equation we can solve. How do you undo squares? You take square roots. So x plus 3 equals plus or minus square root 23. And so subtract 3 on both sides, and there's your solutions. All right, let's take a look here. Try that on your own. Imitate exactly these steps, see what you can do. Pause the video here, please. All right, put negative 14. Complete the squares. And then solve. So we ended up with imaginary solutions here, which is perfectly fine. So completing the square is very useful when what? When you cannot factor. Good. You know, this method of solving quadratic equations was known even to the Babylonians, so it's very ancient. All right, let's try it here. Well, we added the 10 to the other side, but we cannot complete squares because of this too. We can only complete square if the x squared coefficient is 1. So the first thing we'll have to do is divide everything by 2. So let's do that. And now complete squares. So half of negative 5, so negative 5 halves squared, equaling 5 plus negative 5 halves squared, and continue. So this side here will be a perfect square, x minus 5 halves squared. This side will be 5 plus 25 quarters, which you make common denominator and take square root, so and then solve. And then simplify. Square root 45, 9 times 5, square root 9 is 3, so this is 3 square root 5. Square root 4 is 2. So what are the solutions then? 5 plus 3 square root 5 over 2, or 5 minus 3 square root 5 over 2, or you can write that as 5 halves plus 3 halves square root 5, 5 halves minus 3 halves square root 5. Those are all your solutions. All right, try that here then. So again, divide by 2. Complete the squares. And left side is x minus 5 half squares equals this. Make a common denominator of 4. Negative 30 plus 25 will give you negative square root 5. So you're going to have to separate it. So there's two answers. 5 halves plus square root 5 halves I, or 5 halves minus square root 5 halves I. Now you're going to look at this and say, oh my God, this is a complicated process. It's really not that complicated, but when you have fractions, it looks complicated, doesn't it? So if you're a mathematician and you work this hard to solve one problem, you are not going to be solving this problem again and again and again, following the same process. So instead, What mathematicians do is come up with a formula that you can just keep using and not have to repeat the same process over and over again. So that's called the quadratic formula, a very important formula that, especially if you're taking college algebra or any other class or pre-calculus, you want to make sure you have quadratic formula. So when you apply completing the square process to a generic quadratic formula, generic means if you write it as ax squared plus bx plus c, a, b, and c can be any numbers, and you have 0 on one side. A has to be non-zero, otherwise you're not guaranteed it's a quadratic. All right, so if you do the completing the squares here, you end up with the quadratic formula. You'll get negative b plus or minus square root b squared minus 4ac over 2a. People sometimes put this formula to a song with Pop Goes the Weasel. You can search it on YouTube, songs for quadratic formula memorization, and you'll find it. And sometimes tricks like that help you memorize things. All right, so this quantity that's inside the square root is called the discriminant, b squared minus 4ac. So this determines whether you're going to get a real solution, imaginary solution, whether you're going to get two separate solutions or just one solution. So if your discriminant is positive, you're going to get real solutions, two distinct real solutions. If it's negative, you'll get two imaginary solutions. Imaginary means you're going to have something square root I. But if your discriminant is 0, then what happens? If discriminant is 0, then this part is gone and you just have negative b over 2a. You just get one solution. All right, let's solve quadratic equations using quadratic formula then. So identify a, b, and c. A is 3, b is negative 2, c is negative 7. Now use the quadratic formula. Minus b plus or minus square root b squared minus 4ac all over 2a. Okay, so there's your numbers, and now you just have to simplify. What's 88? 88 is 4 times 22, square root 4 is 2. Another way we can write this is if you factor out the 2 across, so that'll be 2 6 plus or minus 2 over 6 square root 22, which will give you 1/3 plus or minus square root 22 thirds. All right, try that on your own. Use the quadratic formula, see what you can do. Assuming you've come back, a is 3, b is negative 1, c is 3. Put that in the formula. Negative times negative. So negative b plus or minus square root b squared minus 4ac over 2a. Simplify. Negative square root 35 means square root 35i. The I is outside the square root. Remember that. And you can rewrite it like that. All right, try that on your own. And then simplify. Or we could have done alternatively factor. Let's take a look. Two numbers multiplying give you 100, add to give you 20. So that's 10 and 10. Factor by grouping, and you'll end up with 5/2. So if you forget the formula, you can either factor, or you can solve it by completing the squares, or you can memorize the formula and use the formula. Try these on your own.